Hello, my name is Aga and my student ID is 660115535 and I am from section 2 of RA6. And this is my final video presentation for Robotics Laboratory course. In this course, I explore four really interesting areas that are shaping the future of AI and robotics: tiny ML, edge device, prompt engineering, and computer vision. Instead of only studying theory, this lab gave me hands-on experience with real hardware, actual code, and practical applications. In this video, I will walk through each topic, share what I did in class, explain the results, and give example of how each concept is used in real life. Okay, so let's begin with tiny ML. And this is my first real ML on a microcontroller. Tiny ML stands for Tiny Machine Learning. It's about running machine learning models on microcontrollers, which are very small, low-power devices. Normally, when what we think of AI or ML, we think of powerful GPUs and servers and cloud computing. But tiny ML let us put intelligence into things like sensors, like wearables, or even toys, things that don't have much memory or power. In the lab, I use Arduino Nano 33 BLE Sense, which has a built-in accelerometer. I recorded gesture data for left, right, and up hand movements. Then I train a classification model using H-Import website, a platform that makes it easy to upload, train, and deploy models. The best part was seeing the model run smoothly and directly on the board. I could wave my hand and instantly see the prediction, the direction. This made me realize how even a small chip can become smart with the right tools. In real life, this is similar to how fitness bands detect your emotion, or how sense smart like turn on when they sense movement. Okay, so the next thing is the edge devices. Edge devices are like similarly the devices that can process data locally, meaning they don't rely on the cloud or a server to make decisions. Why does that matter? Because it makes things faster, more private, and more energy efficient. When I deploy my trained tiny ML model onto the Arduino board, it became an edge device. It didn't need to send data to a server to figure out what gesture I made. Everything happened locally in real time. In real world terms, think about self-driving cars like Tesla or BYD. They can afford to wait. They can afford to wait for a cloud response when detecting a pedestrian. They need an instant response. Or industrial robots that react to sensors on the fly. Even like basic smart home devices use edge computing to respond instantly, like when a doorbell camera detects motion and send you a notification. Okay, so the next thing is the prompt engineering, or we can say communicating with AI clearly. So next, I work on prompt engineering at first. I thought that would be the simplest part, just typing something into ChatGPT or the DeepSeek or like Gemini. But I quickly learned it's more of an art than I expected. Prompt engineering is all about how you communicate with large language models, the LLMs. The way you ask something completely changes the output. I tested like basic prompts like summarize the test, but also try more structural ones like as a data scientist, give the CSV data, what insights can you generate? The better and more specific the prompt, the more accurate and useful the response is. This taught me that AI isn't just about training models, it's also about interfacing with them like effectively. In the real world, prompt engineering is already being used in like customer support box, coding assistants, and creative tools like generated AIs. Even in future robotics, like prompt-based control might allow us to interact with machines using plain language, like what most of the normal people can communicate. So it will make it more simpler and more efficient. For example, like imagine saying, find the red ball and bring it here, and the robot understand powered by both vision and prompt logic. So it is like the future like control for the robots. Okay, so the next thing in the next topic is like on the computer vision. It's about teaching machine to see. Okay, so computer vision was probably the most visual and exciting part of the lab. It is the field of teaching computers to see and understand images or videos. In this module, I used OpenCV and a mobile net model to detect objects in real time using my webcam from my computer. The model could identify everyday objects like phone, bottles, like wallets, like cubes, many other things, and even faces, and draw like bounding box around them. We call it like the contour in computer vision. I learned how lighting, distance, and angle can affect the accuracy. So it's not just about the model. The environment matters a lot too. And this hands-on part make me realize how computer vision is used everywhere, from security system, quality inspection in factories, to autonomous vehicles. It's very useful in every field of the technology. One thing I appreciated was seeing the model work in real time. It wasn't just code; it was something interactive. In future projects, I love to combine this with other topics. For example, like gesture-based control using like both vision and motion data from the sensors. Okay, so looking back at the whole lab, I think like what made this code different was the balance between software and hardware. It wasn't just like I wasn't just writing code. I was seeing it work on real devices, on real physical devices, making prediction, like reacting to inputs. It was really exciting and really like understandable. All for topics like tiny ML, edge devices, prompt engineering, and computer vision connects to each other in like meaningful ways. You can imagine building a smart robot that detects gesture with like tiny ML, like and process data locally on an like, edge device and understand natural command through like prompt engineering. We don't need to use like complex code command or like any other like the complicated language that only the programmers or developer know, or like just maybe your English language, or you are maybe even your own language can like control the robot or a boat, a microcontroller boat, to do the specific task. And also like to use computer vision, you can seize and recognize objects using computer vision. So when we combine the computer vision and the sensor readings and many other things like input, we can make it like really like, absolute like efficient and really useful tools. This is not like science fiction anymore that we used to see in the movies when we were back in the childhood. It's real and it's doable, even to a normal person with no knowledge or with just a little knowledge on the technology. In fact, this lab helped me shape a vision for future projects. For example, in my like robotics project, I could combine a camera feed like the real-time live camera feed with a lightweight model running on a Raspberry Pi, or even maybe even like Arduino Uno or like Arduino Mega, anything triggered by voice or gesture. Also, I became more aware of their challenges, like optimizing for like limited memory, like because like in the real world we cannot rely on like so many too much amount of memory because it make it less efficient. So and I also learned how to handle the noisy inputs and designing useful like interfaces which are like familiar for the users. These are real world problems that engineers deal with every day in today's world. And it helped me learn not just what AI can do, but how to actually use it on real devices, from sensor to models to inputs. I now feel like more prepared to build like complete like systems. So maybe in my third year, I'm like aiming to integrate the hardware and the software. I'm planning to do that one because it's more interesting and more like powerful and efficient to the real world application. We can't just rely on coding and software. We have to integrate. So there have to be a bridge between that, and it will make it what like stand out in this world. And thank you so much. And this is all for my final project presentation. And this is what I have learned throughout the course. Thank you so much.